Okay, so this is the apparatus for measuring sublimation pressure of argon vapor in equilibrium with solid argon. The apparatus includes the main chamber, which is separated into two parts. Inside the cylinder there is a wall, and on the left hand side we have a chamber which will be filled with nitrogen gas. On the right hand side we have a chamber which will be filled through this tube with argon gas. So if you look at the connections of this apparatus, this tube is of course connected to open manometer. So this tube goes to manometer, and the other tube goes to the connection with argon cylinder. So when we'll be filling the right hand side chamber with argon, we will be opening handles to allow argon gas to go through this tube and into the chamber. And on the other side we have this tube. Okay, it is connected also to this manometer and to the cylinder with nitrogen gas.
So the first thing you want to do is work with the apparatus until you understand how all of these connections work. Just trying to memorize that through a video is not going to be very helpful. You have to come in and play with it. As you recall, we need to create a seal between the Doer and the cap that's above the chamber. We do this with rubber gloves from which we simply cut off the fingers. That will do it. And we need a good number of these, about 5. So you can see Dr. Miebel applying them one over the other. This should be done before you do the experiment. There may be liquid nitrogen already in the Doer, and if so, you need to exercise caution because you could be applying a good deal of force and you don't want to spill the liquid nitrogen. So Dr. Miebel's putting on about 5 of these defingered rubber gloves to serve as seals. So before you begin the experiment, be sure to measure the barometric pressure. If you forget to, the experiment will be wasted. Now, you learned how to do this last semester, so we're not going to teach you again. But be sure you do it and see us if you have questions.
So first of all, we need to purge both sides. Okay. Now this is connected to the vacuum pump. So when we switch on vacuum pump, this connects to argon pump and this connects to the now when we pump, this is in order to open this to vacuum line, we need to have it in this position so that this is open. Okay, so let's switch on the motor. The reading of the manometer, they need to take the difference between heights of liquids here and here, heights of mercury in this tube, and this difference is then subtracted from atmospheric pressure. So the larger the difference, the lower the pressure. Very large difference here. When it's subtracted from atmospheric pressure, we'll get pressure well is close to zero. Right? So now we can, so we evacuated our system, so now we can switch off the. So now we are filling system with argon.
With argon. So remember, lefty loosey, righty tighty. Make sure this is loose initially. Okay, now we have high pressure from the tank all the way up to this valve. Now we can make sure this is closed. Okay, with that closed, we can now righty tighty this until we begin to get some pressure out to here. Okay, it doesn't have to go far. It's now off. So now we're ready to introduce gas pressure. As much as I can add, I would have to add more pressure here. Is that sufficient?
You can add a little more.
Okay, so I close this valve, then I introduce more pressure, then I open this again. I never leave this open the whole time because I can have a sudden pressure change. Okay. That's as high as it'll go. If I want more, I need to do this. Think that's enough, Dr. Meeble?
Yeah, that should be enough.
Okay, so there we go.
Mm-hmm.
Then we need to do the same thing with the nitrogen tank. I need to be here, loosey. This is nice and loose. That is closed. Can open this, pressure's up. That's all we need. That is closed, in fact. Tight in until to the right until this needle comes just off the up a little bit. It's not going up. There we go. Just ticked off. So now I'll move over here and we'll see what we can get. There we go. How much do we want?
Just above atmospheric pressure.
No more?
That should be enough.
That should be enough.
That
Okay.
should be enough.
So Dr. Meeble and Dr. Gomez are going to insert the Doer with liquid nitrogen very carefully. And you see the nitrogen already boiling. It can become quite vigorous. You want to be careful. Meanwhile, Dr. Mo Gomez is going to maneuver the lifter so that the Doer can sit on top of the jack. That's what I tried to say. And then you will slowly raise the jack, ensuring that the boiling is never too vigorous. And now you see the cold nitrogen coming through the very spout at the top as you raise the Doer completely. So the next step is layer by layer to maneuver the gloves, the rubber gloves, so they form a seal between the Doer and the rim above the chamber that holds the argon nitrogen, layer by layer, starting from the top one, starting from the outermost, and working toward the innermost. Achieving a good seal is critical. If you're not careful, and sometimes even if you are careful, you can puncture holes into the gloves. If that happens in only one layer, it may be okay, but several layers and you'll be in trouble because you will need a good seal. And you have to be alert throughout this whole process because that liquid nitrogen can be dangerous. So alertness is critical. So next we place a funnel into the spout, and we're going to add liquid nitrogen little bit by little bit. Much of it has boiled off at this point from coming into contact with relatively warm surroundings. And we'll need a lot more. Now this is a little acrobatic, but you must be secure. And never let the liquid nitrogen pour over these gloves. They're porous. So they'll insulate you fine, but not if liquid nitrogen pours onto them. Now you notice that right now the pressure on the argon side is decreasing rapidly as we are adding liquid nitrogen enough. So you should ask yourself why that is. At one point, you'll all of a sudden see a rapid change. And one hint is that the triple point of argon, as I recall, is 84 K. In liquid nitrogen, the boiling point is 77 Kelvin. So we can get below the triple point of argon with this adding here. Sometimes you can see the level if you're uncertain inside. Now I'm not sure I can see it very well now, but when the level gets low enough, you can judge it from the holes on either side. So we really need to get as much in as we can, not to the point that it overflows the top of the spout, of course, but later in the experiment, we're going to evaporate liquid nitrogen by adding a vacuum. And as the liquid nitrogen in the Doer evaporates, we can achieve yet colder temperatures than 77 Kelvin. And that will be necessary for the experiment. So we need to begin with a very full Doer. So that's what Dr. Miebel is achieving right here. when we begin taking readings, your main task is to note the height of the column of mercury. So you'll need to note the level of the bottom right here, the level on the left and the level on the right for argon, and then the level on the left and the level on the right for nitrogen. So those are the details that you have to have at every point. Dr. Miva will demonstrate a good way to do that.
So you can see that on right hand side tube we have the height at 7.8 centimeters. And on the left hand side, so on this manometer we have positive and negative numbers. Zero is here. So on right side we have plus 7.8, and here we have minus 10.6.
It's a good idea to take a snapshot with your cell phone. You can go back, you can blow the picture up, you can see exactly what it was. But yeah.
So the difference between heights of the liquid is plus 7.8 minus 10.6. This gives you 18.4 centimeters or 184 millimeters. And then when subtract this 184 from atmospheric pressure, you get the pressure on the argon side of the system. So please pay attention that here the pressure in the argon chamber is lower than atmospheric pressure, because this side is connected to the chamber and height of liquid is higher here. So atmosphere pressure is harder than argon flow from the chamber. Here on the nitrogen side, because this side connected to the apparatus, the nitrogen chamber, and this side is connected to atmosphere. So in both chambers, pressure is below 1 atmosphere. We will need to remove this funnel. And eventually when we pump, we will need to put the stopper here, because pumping will be through this tube, and we will be pumping from the Doer through this tube, and in such a way we will be decreasing pressure. But if I put stopper now, it will pop up, right? So we will need to let nitrogen to boil out, because we put a lot. Or we can start pumping and then put the stopper. Let's make sure that our connections are correct. Right? So this is connected, this is closed. So we're not pumping from argon side. Also, this is closed. This is closed, and therefore we are not pumping from the nitrogen side. The only thing we want to pump is the Doer itself. Okay, it's working.
So notice the nitrogen side. This registers our temperature. Notice the mercury on the left going up and on the right going down. This indicates that the temperature is dropping. inside the system. And that's because the liquid nitrogen is being evaporated. And we want the temperature to go as low as it can go. But there is a trade-off, because if you evacuate for too long, you will evacuate so much liquid nitrogen that the chamber is no longer in contact with the liquid nitrogen, and that will be a failed experiment. All right, it's up to 66 on the left. Going up towards 67. Up to about 68 now. Back to the nitrogen side. Just about 70 now. After preparing the system, and before taking the first measurement, as a precautionary measure, we re-evacuate on the argon side and add a little extra argon. This is in case there has been a small leak of air into the system. Air, being mainly nitrogen and oxygen, would artificially raise the pressure on the argon side. Not so serious on the nitrogen side because air is mainly nitrogen. You should notice after re-evacuation or after addition of extra argon that the system will re-equilibrate back to its original pressure.
-7.8 and minus 30.8.
73.1
and 22.2.
22.2. After the first measurement, which is the lowest temperature one, we need to heat the system so that the nitrogen side's pressure increases by about 30 torr. We do this in a low-tech way because it's sufficient. We simply heat a long screwdriver with hot water, any metal rod would do, and insert that into the spout, wait a few minutes, voila. You'll notice, by the way, that the cap has become frosted from all the pumping out of the nitrogen.
No, 71.2.
71.2.
And here we have 24.1.
24.1.
And on argon side we have plus 25.8.
25.8.
And minus 29.8.
So you will take at least 6 data points, between 6 and 10, where between data points the nitrogen pressure decreased by approximately 30 torr. You need to know the decrease exactly, but it might be 29.2 or whatever, but 6 to 10 points. And then when you're all finished, we need to disassemble the apparatus. And that is critical. So there is a possible danger, because when we lower the Doer, all of a sudden the temperature of the chambers will go rapidly up. And if this is a closed system, the argon can rapidly sublime and you can pump the mercury right out of the flask, especially since we added argon at one point, if you remember. So we want to be very careful and open up and reevacuate the system before we remove the Doer.
Okay, so now pump is connected to the system, but we want to open nitrogen side to the pump. switch on the pump. Now we need to remove gloves. Some liquid nitrogen left. Yeah.